Today is going to be 101-1, and we're still examining exponential and logarithmic functions, but we're going to examine the properties of logarithms, and we're going to practice expanding logs. So that's our objective today. We're going to expand logarithmic expressions. So we're going to introduce our algebraic properties of logarithms. Now, logarithms have special rules in the way that we can expand and combine them together. So the product rule, according to it, if I have a function, say function g, right, we're going to define that g of x as log base b of x. And if I have function g and I'm multiplying two things inside of it, algebraically speaking, I'm allowed to break it into two separate functions with input u and input w. Now, in other words, that log base b with u times w is log base b of u plus log base b of w. The quotient rule says if I have some function g and I'm dividing two inputs, u and w, I can break it up into two separate functions, g of u minus g of w. Now, looking at that in terms of logs, log base b of u divided by w, that equals log base b of u log base b minus log base b of w. And in the power rule, it allows me to take whatever the exponent is and move it to the front of my function, so I would get w times g of u. And so in this instance, log base b of u, I can take that w and I can move it to the front. Let's I'm going to briefly just look at quick instances of these properties, right? So here's the property just in a different format. Log base a of m times n is log base a of m plus log base a of n. So if I wanted to express this in terms of the sum of logarithms, because I'm multiplying here, I can break this into two logarithms. Both have that log base a. This was my u, this is my w, this is my m, this is my n. So m and n. But once you break it apart, we still have to check to see if you can simplify it. Well, that 9 is 3 squared. The 27 is 3 to the third power. So those are going to cancel out, right? So the log base 3 is in the 3 is log base 3 in the 3. So I get 2 plus 3, which is 5. So just know after you've expanded, we may be able to simplify. The power rule, right? I can take that value p and move it to the front. So this negative 3, I can move that to the front because it's an exponent. If it's not written as an exponent, change it into an exponent. So I can move that 1/4 to the front. So we may have to do those. So roots, every single root, you're going to have to change it into a type of power where there's a base and the exponent. ln of x, I can take the 6 and I can move it to the front. And then expressing this as a difference, log base t of 8 over w. Whenever you see subtracting, it implies that we have a value in the denominator. So because this is in the denominator, my log is going to be expressed as a negative. This is in the numerator, my log will be expressed as a positive. So a positive log base t of 8, denominator minus log base t of w. So let's look at a few examples here. So first example, we're going to expand the following using the properties of logs and simplify. So I do see that I'm dividing here. This is in the numerator, so it's going to be positive. This is in the denominator, so it's going to be negative. So I can break that apart into two logs. They both have log base 2. And why did I say two logs? Well, I have two things. I have an 8 and I have an x. And so the first one, log base 2 of 8, it's positive because it's in the numerator. The x was in the denominator, so minus, and then I can say log base 2 of x. Well, if there's any form of simplifying that I can do, I need to. So this 8, I can say that that's log base 2 of 2 to the third power. And the log base 2 and the 2 will cancel out, and so I get 3 minus log base 2 of x, which could be my answer. Or you can write it as negative log base 2 of x plus 3. All right, next one. So expanding this one, the 10 and the x squared are being multiplied. So these are both in the numerator, so I can break it apart in terms of pluses. So log base 0.1 of 10 plus log base 0.1 of x squared. Well, I have an exponent here, so I can take that and move that to the front. So I'm going to get log base of 0.1 of 10. I'm going to make that a little smaller. And then plus 2 log base 0.1 of x. Well, that doesn't simplify, but maybe this simplifies. So let's do that off to the side. So log base of 0.1 of 10 equals some number I don't know. Well, I'm going to have to take 0.1 as a base to both sides, so 10 equals 0.1 to the x power. Well, what's 0.1 as a fraction? It's 1 over 10. I can bring that 10 to the top, so I get 10 to the first power equals 10 to the negative 1. 1 equals negative x. Divide by negative, negative 1 equals x. So this is going to be negative 1. And that's going to be my answer. For this next one here, now I personally feel that it's easier doing it this method. I could just bring the 2 into the front, and then it's 2 times everything that you have. You could do that if you wanted to. Or what you can do is you can take the 2 and you could go ahead and bring that and you multiply it by every exponent that's inside my expression. So this would be rewritten as ln of 3 squared over e squared x squared. And so now, breaking it apart, this is in the numerator, so it's positive. This is in the denominator, so it's going to be negative. There's 3 things, 3 squared, e squared, x squared, so there's going to be 3 logs. So I have ln of 3 squared. We said it's positive. These 2 are negative, so minus ln of e squared minus ln of x squared. Now I can bring these to the front. So I have 2 ln 3 minus 2 ln e minus 2 ln x. This cancels out. So then I'll get 2 ln 3 minus 2 ln x, and then I have my minus 2. And that's going to be my answer. This next one, well, I have a root. So I said when we have roots, we need to convert those into some sort of form of power, right? So it needs to be written as an exponent. So log of 100x squared over y x to the 5th to the 1/3. Now, if we're able to simplify things, we should simplify them. Like, for example, this x squared and this x to the 5th, that simplifies. Now I can take this 1/3 and I can distribute it with the other exponents. So I'm going to get log 100 to the 1/3. I'm going to write this better. So I'm going to get 100 to the 1/3 over y 1/3, and then x, that's 3 over 3, because 3 times 1/3, so I get x to the 1st. So now I can break it apart. Remember, this is positive, this is going to be negative. And there's 3 things, 100 to the 1/3, y to the 1/3, x to the 1/3. So there's 3 logs. So I'm going to have log 100 to the 1/3 minus log y to the 1/3 minus log x. Well, now I can move the exponents to the front, so that can move to the front, that can move to the front. So I get 1/3 log 100 minus 1/3 log y minus log x. This will simplify. I can rewrite, because this is log base 10, right? So 1/3 log base 10 of 10 squared. Well, those will cancel out. So I get 2 times 1/3, so that gives me 2/3. And I still have my minus 1/3 log y and my minus log x. Looking at example number 5. Now, we're kind of at a crossroads here, because this says x squared minus 4. And the issue here is how do you expand that, right? I never talked about an issue in which we expand a log when we're adding or subtracting inside the log. So, and I know you're probably thinking, well, maybe we're just done, right? You just can't expand it. So the question is, can I turn it into multiplication or division? Because if I can turn it into some sort of multiplication or division, then I would actually be able to expand it and do what I needed to do. And so in this instance, I could actually rewrite this log, because this factor means you're expressing it as a product or multiplying. So that could be written as x plus 2 and x minus 2. Now that I'm multiplying those, you can break it apart with addition. So log base 117 of x plus 2 plus log base 117 of x minus 2. And that's our results. So just understand that if it's not written as multiplication or division, you may have to employ other tactics to be able to separate them. So in conclusion, what concepts were discussed today? Well, we looked how to expand logs. We examined the product property, the power rule, and the quotient property of logarithms, and how we're able to expand and break them apart. So in your own words, what I want you guys to do is go ahead and explain what the product property of logs are. And then after you've expanded the log, what are some things that you should check for in terms of trying to create your completed answer? So I'd love to hear your feedback, and as usual, if you have any other questions, please leave them in the comments.